This is my simple temperature logger, and the focus of another project in the installment of projects I build but never really want to make a video about, with which I mean DIY one day build. In today's video, I'll be going over a simple IoT-based temperature logger. The temperature logger, like the name obviously implies, states that this was made to measure temperature of a given environment and to log that data to the backend of a platform for future data analysis or whatnot. Quite simple, right? That's because it is. Speaking of the process immediately, here's how I went from nothing on my table to the final temperature logger you can see right now. Starting off, I picked up my mini drawing board and drafted what the design would look like. Any features and components I roughly just listed out. To summarize, I just needed to log temperature, have Wi-Fi capabilities, be portable, quite some battery life, amongst some minimal things. With that done, I brought out the components I needed. But before that, if you want to support the channel and if you like what I do here, if you also want to see me build cool stuff like Toby from the last video, go check it out. Make sure to subscribe, leave a like, and drop a comment with your suggestion on what next I can build. I'm pretty much open to all criticism as to get this channel going forward and making the content even better. Alright, let's get back to the components needed. Starting off with two 18650 LiPo batteries, a 1.3-inch OLED screen, DHT11 temperature and humidity sensor, a buck converter I didn't end up using, a 2S LiPo battery holder, a Type-C port, 10K resistor, LiPo charge and discharge module, then some jumper wires and a breadboard for testing. Here's the problem. I intended to use the two batteries in parallel to double the capacity, but I had a 2S LiPo battery holder. So what do? I use my patent pending conversion method, and by that I mean I just cut the leads that are in the series part and then I solder wires to make them into a 1S 2P battery holder, so two batteries in parallel instead. With the wires tied and soldered in, I used some super glue to hold the cut spring in place, but that fell apart miserably, so instead I just used some 2-part glue and that did the job just fine. With that done, I laid out the components on top of the battery pack. With this, I was able to get a sense of the size of the variable board I'll need and how to make the main circuit board really small. And after a wee bit of consideration, I started soldering the female 2.54mm headers that I used to connect the ESP32 and charge the discharge module to the variable board. I then proceeded to solder wires to the Type-C port, which got connected to the charge and discharge module, alongside the output wires and battery input. With that done, the next thing was to take care of adding a switch via two headers, which made it a modular switch, meaning I could just pull it out from the headers and then plug it back in, and this was to ease the process of assembly to the main board. Due to the small form factor I was going for, I had to trim the variable board even further to ensure that it was as small as possible. It's similar to my recent video where I made a small form factor simple heart rate watch, which you can go check out after this video. The next thing I did was to add the main and only sensor of this build, the DHT11 temperature and humidity sensor. After soldering all the necessary components, I checked the temperature readings and they looked fine. But as we know, with every build comes some problems. Before the problems finally came up, I was actually able to solder the connections for the OLED screen, and once that was done, I proceeded to measure the parts of the build and then throw together a 3D model with the space for the screen, Type-C ports, screw holes, and the HC temperature sensor. After 3D printing the case, I tried to copy it all together, and that's where problems started. Essentially, the 3D model had a lot of faulty measurements in the form of too tight tolerances, which forced me to use a heat gun to create some more leeway. But not just that, the HC11 temperature sensor that had been malfunctioning earlier just occasionally swung into full delusion. Gotcha, bitch! And in full effect. And after putting everything together, the charge module also started malfunctioning. So at this point, I just got fed up and took the entire thing apart. And in order to bore you with the exact same process, I essentially replaced all the faulty components and read another circuit board. I didn't just have another DHT11 temperature sensor on me to replace it with, so I just slapped it out and put in a DS18B20 temperature sensor. I made some modifications to the 3D model, adding a mounting hole and some supports at the top for the sensor because it had a different shape and a much longer cable. Once that was done, I glued up everything inside the new case with the help of my heat gun 1 or 2 times, and voila, it was done. I do not intend to release the files for this project as they are way too janky and unrefined. If the video does gain traction, I will revisit it and correct all the flaws, probably adding a Node-RED user interface so you can actually have a way of creating IoT projects fully open source with no limitations on what you can do. But here's the final product. After doing a little bit of programming and some pixelographic designs, I did this logo and added the Wi-Fi connection and reconnection protocol I usually use for an online and offline mode too. The device functions like so. Once it starts up, it searches for the set Wi-Fi and tries to connect using the saved credentials. If it's successful within 60 seconds, it gets into an online mode, and if not, it switches to an offline mode. In offline mode, the temperature is read and simply displayed on the screen. But in online mode, it will transmit the temperature data to whatever IoT platform you choose and will maintain the internet connection. If the connection fails, it will immediately start a subroutine that tries to keep reconnecting it to said Wi-Fi. But that's all I've got for today. If you want to see any more of the one day build videos, drop a comment, let me know what you would like to see next. If you watched this far, thank you for watching, leave a like, subscribe, and see you in the next video.